Our first transformation we're going to be looking at is a reflection about the x-axis. Now, when I have this parabola right below here, when I have this parabola right here, what we see is that here's my shape. And I have highlighted 5 points, and I'm going to reflect these 5 points about the x-axis. Now, this is the x-axis. If I reflect them about the x-axis, they just simply change places. It's like a piece of paper that is folded along this line, the x-axis. Now, what I'm going to do is reflect about the x-axis. I'm going to change the graph, and then we'll get on to the equations and the mathematics. But so far, if I take this point here, this point, if I reflect it about the x-axis, it's going to land right about there. Next, I'm going to take the point at -1, 1. It's going to be reflected at -1, -1. 0, 0 is going to stay where it is, right? Because it's on the mirror. This point 1, 1 will turn into 1, -1, and the point 2, 4 will be reflected in point 2, -4. And there, if we notice, now besides my terrible drawing, we'll try to do it better. If we notice, I have a parabola that has been reflected. Now, it doesn't have to be exact, but you definitely should show the points. So when does this happen? So my original graph was y is equal to x squared. When I reflected it, I made a equal to -1. I make a negative. So the new function form is y is equal to -x. The coefficient of interest is when a is negative. The description, we call this a reflection about x-axis. And from point form, we can start off with y is equal to x squared. And after our transformation, the new functional form becomes y is equal to -x squared. So this is really our transformed graph. On our original graph, we started off with points x, y, and they were transformed into x, comma, -y. That is, take for instance this point, -2, 4. When we reflected it, it became -2, -4. The mathematical operation here is we simply, when we reflect, we multiply the y values by -1.